The vendor slide is comforting. In big, calm letters, it says that system prompts are internal only, safely hidden from users and attackers alike. Around the table, heads nod. The Copilot rollout moves forward, and someone writes a tidy line in the risk register that says prompt exposure is a low concern. 6 months later, a red team exercise shows that a clever series of questions can walk your model right up to the edge of describing its own rules, and a debug log turns out to contain the exact text everyone thought would never see the light of day. The gap between what you believed about your prompts and how they actually behave suddenly feels very real.
Welcome to prompt leaks and side channels, when internal only isn't. This is part of the Wednesday headline feature from Bare Metal Cyber Magazine, developed by Bare Metal Cyber. In this conversation, we are going to treat prompts, wiring, and behavior as first-class security surfaces. We will talk about why hidden instructions in a large language model, LLM, stack are not nearly as hidden as people assume, how side channels emerge from ordinary design choices, and what leaders can do to design for bounded exposure instead of betting on secrecy. The goal is not to scare you away from artificial intelligence, AI, but to give you a mental model that holds up when the system is under pressure.
Prompt safety started out as a narrow technical concern. Early discussions focused on prompt injection, jailbreaks, and how to keep a model from simply dumping its system prompt when asked. Many leaders still think in those terms. Either the model reveals the whole thing in one catastrophic burst, or it does not. In practice, the risk is more subtle. Prompts, examples, and orchestration glue encode policy, business rules, escalation thresholds, and even negotiation strategies. The model does not need to print the prompt for those to leak. Every answer is a reflection of what the system has been told, and a determined observer can learn a lot from those reflections over time.
It is tempting to file prompts alongside other internal artifacts. We already have internal networks, internal documentation, and internal dashboards. When a team says that the system prompt is never shown to users, leaders mentally place it in that same locked closet. The trouble is that prompts are not inert configuration files. They are active instructions that shape how an LLM responds to every question. The more detail you cram into them, the more your model's behavior becomes a living shadow of those internals. Users never see the raw text, but they constantly see and probe the shadow. The illusion gets stronger as you wrap your models with more layers. Middleware, guardrail services, policy filters, routing logic, and retrieval pipelines create a sense of distance between the user and the prompt. It feels as if the raw instructions are buried deep below the surface. In reality, every layer is another place where behavior can diverge in visible ways. Differences in wording, formatting, error style, or response time are signals. A patient adversary can turn those signals into a working model of what the hidden instructions must be saying. Side channels are not new. The novelty is that we now have conversational systems built to surface subtle differences instead of hiding them. Leaders often overestimate the strength of environment boundaries as well. It is easy to say that a model is internal only, that a prompt is only used by employees, or that sensitive content sits behind a trusted front end. But in real organizations, internal and external are not cleanly separated. Contractors use the same tools as staff. Debug logs get pasted into tickets. Sandbox environments end up wired to production data. Screenshots of hidden behavior flow through chat channels without anyone thinking twice. Somewhere along those paths, your internal logic crosses into contexts where an attacker can see it, store it, and use it against you. When people hear prompt leak, they usually imagine the worst case, a reply where the model spits out the entire system prompt verbatim. That can happen with misconfigured guardrails, but it is not how most leaks occur. In most settings, prompts leak in fragments. A red team or adversary sends many prompts that ask the model to explain its reasoning, describe its policies, or role-play as somebody with special powers. Each answer adds a few clues. You learn that certain requests require manager approval, that some jurisdictions trigger extra caution, or that specific keywords are considered highly sensitive. Over time, those clues add up to a surprisingly complete reconstruction of your internal instructions.
Integration mistakes create another big category of leaks. Application logs that echo entire request payloads, explain mode features that show internal message chains, verbose error pages in staging environments, or notebooks where data scientists paste final prompt templates for convenience all become exposure points. None of these look like an attacker breaking the model. They are ordinary engineering decisions that give someone with access to those artifacts a transparent view into what you thought was hidden. Once adversaries gain that view, they can tune their probing to exploit exactly how your system thinks.
Even when prompts never leave the system boundary, they leak through policy encoding. Imagine an incident copilot that sounds extra cautious whenever certain asset types or regions appear in the request. If an attacker sees that pattern, they learn where your organization believes the highest risk lives. A fraud assistant that refuses certain categories of questions while answering adjacent ones freely is quietly drawing a map of your guardrails. From an attacker's point of view, the text of the prompt is less important than that map. The value lies in knowing what your systems are trying to protect, what they will never do, and where they hesitate.
Side channels turn ordinary behavior into powerful oracles. Consider a workflow assistant that sometimes calls an internal tool and sometimes does not. If responses are noticeably slower or formatted differently after tool calls, an attacker can probe which kinds of inputs trigger those paths. Over many trials, they can infer which conditions, labels, or risk scores sit behind the scenes. To them, those timing and formatting differences are not quirks. They are a way to test hypotheses about your internal policies without ever seeing a line of code or a configuration file. Error handling is another rich side channel. Does the system use the same bland response for every failure, or do different paths get different language? If a user hears one message for compliance issues, another for missing data, and a third for blocked content, each of those messages is a beacon. An adversary can push the system around until they can reliably trigger each type of error. That lets them map where your guardrails sit, where you fall back to more permissive behavior, and where you escalate to humans. They learn to aim their real attacks for the least governed branch. Even user experience tweaks meant to feel helpful can become side channels. You might add extra disclaimers when regulated data types show up, or change tone when the model detects a high-risk action. You might present different suggestions for different roles or regions. Every one of those differences is observable. If a human can notice a change in wording, structure, or timing, an automated probe can notice it too, and count it at scale. From that point on, your LLM becomes not just a helper for your staff, but also a silent reporting channel for someone trying to reverse engineer how you think.
So, what does it look like to design for bounded exposure instead of pretending prompts and side channels are invisible? The first step is a mindset shift. Assume that motivated outsiders and curious insiders will eventually see a meaningful slice of your prompt logic, either directly or through behavior. Then ask, what happens to your risk posture if that occurs? If the answer is that an attacker suddenly gains your exact detection thresholds, escalation conditions, and negotiation playbook, you have loaded too much value into those instructions. If the answer is that they mostly confirm what a sharp observer could already infer from your public policies, you are in a much safer place.
A practical rule is that prompts should contain abstractions, not secrets. If your copilot needs to understand that high-value customers in a certain jurisdiction get extra fraud review, capture that as a policy concept, not a table with precise revenue thresholds and customer names. If your incident assistant needs to know how to triage active intrusions, encode the decision flow, not the specific detection queries and signatures. Credentials, live indicators, and sensitive tactical content belong in systems with their own access controls, logging, and oversight. They do not belong in a block of text that you hope nobody ever extracts or reconstructs.
Once you reduce the amount of sensitive detail in prompts, you can turn to the behavior of the system itself. Normalize error messages so they do not cleanly distinguish between types of failures that attackers care about. Smooth out large latency differences when tools are called so that adversaries cannot easily tell when a classifier has labeled something as sensitive. Decide intentionally where your system is allowed to express clear policy boundaries to users and where it should blur them to avoid becoming a perfect oracle. This is not about making everything opaque. It is about balancing transparency for legitimate users against the intelligence value it offers to hostile probes.
Governance is the last piece leaders often overlook. Many organizations now have prompt libraries scattered across repositories, notebooks, configuration files, and vendor dashboards. Few treat those libraries with the same discipline they apply to firewall rules, identity policies, or production configurations. A better posture treats prompt logic as high-value configuration. That means version control, peer review, change approvals for risky edits, and clear classification. It should be possible for you to point at a prompt and say who owns it, who can change it, and when it was last audited for sensitive content.
If you bring incident response thinking into this space, the key question becomes very concrete. If this prompt leaked tomorrow, what exactly would an attacker gain? You should be able to answer in terms of capabilities, not just embarrassment. Would they know how your fraud systems prioritize cases, how your incident handlers escalate, or how your customer support teams negotiate? Would they learn how to avoid your detection thresholds, or just that you care about things any attacker would assume you care about anyway? Those answers are the difference between a nuisance leak and a strategic failure.
When leaders internalize this way of thinking, the conversation around prompts and side channels improves. People stop asking only whether the model could ever leak the prompt and start asking what they have chosen to encode there. They stop tolerating prompts stuffed with sensitive parameters, exceptions, and workarounds that nobody has documented elsewhere. They start pushing for patterns, abstractions, and governance in the same way they do for identity, network, and data controls. The guiding idea becomes simple. We cannot guarantee that internal only will stay true forever, but we can control how much power that phrase carries when the illusion breaks.
A practical next move is to sit down with your AI and security teams and build a simple inventory. Where does prompt logic live today? Which workflows depend on it? Who is allowed to edit it? How do you know when something sensitive has crept in that should be managed elsewhere? From there, you can start shaping behavior and exposure instead of being surprised by it. That shift from wishful thinking to deliberate design is what turns prompt leaks and side channels from unknown threats into knowable, governable parts of your environment.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.